And I'll throw out some words: population, sample, parameters, statistic, discrete, continuous, qualitative, quantitative, categorical, stratified, cluster, and others. I mean, there was a lot of vocabulary. Turns out that on the stratified cluster, those are the two hard sampling techniques, I'm going to call it. Get those confused. And there's not a lot of homework questions for me to draw upon. So you got the 4 that I selected for you, and then you've got about 9 on your packet. Easy for you guys to just Google or YouTube those topics and then get some additional ones and get maybe a different perspective from a different author. So I encourage you to do that. Yeah, and that's what Jan was wondering. Out maybe after class she has a particular one. How come this was the answer in the back of the book? Or how come I don't quite get this concept? I'm struggling with it. So after class, after I'm done with this lecture on the next 2 sections, 2.1 and 2.2, then I hopefully will be able to address and clear that up for you. So here's something else too. I've got to send myself a note by the class. All my classes, I'm going to send you guys the PDFs for the instructional readers, this thing right here. I've had students over the weekend say, I sent Will Crawford and he's probably inundated in his position no matter what. And then have a number of my students send them emails, which I told you to do, to try to get to the bottom of this, because what's happening? I have students that are getting the wrong reader. A 150 student got a Math 25 reader. Well, that's weird. Why? So now they got to wait for the next one to come around and be shipped. So here's what I'll do with you guys. I'll send you my PDF for Math 15. It's a pretty big file. So be prepared for that. Look in your junk mail or so I'm going to send you that today, this afternoon. So those of you that don't have this will have all the pages that I'm working out of, and then you can decide whether you want to print them out or not, whether you want to still order yours from the bookstore or not. So free. I'm not going to charge you. It's just going to send it.
Thank you.
It's an easy solution. So I got to say, readers to all my classes. So today, today 2.1 and 2.2, whatever those things are about. Graphs, there's a lot of graphs, different kinds of graphs that we'll look at. For the most part, I'm going to ask you to interpret some common ones, like a pie graph, bar graphs. Those are pretty common. If you look, and I have some copies too, but if you look online or even Google statistical graphs, you're going to get probably 100 varieties of different ones. And your job in this semester is to be little problem solvers. So maybe you'll be able to look at any graph and interpret what's going on better than what you have in the past. Let's see, bar and pi are common ones, and frequency tables. So these would feel like, in algebra, you'd have like a t-table. You put it looks like this. In algebra, you have x's and y's. So it's going to be similar. Where I'm going to make it this way, a t-table. There might be another one over here for us. And there'll be information down here and some results and some results. So frequency tables, there's something else called a relative frequency table. So that means I have to define relative frequency for you, which I will. And yeah, so we'll do that in 2.1. And then let's see, 2.2, I think is just a continuation of other kinds of graphs. I'm just looking Oh, yeah. See, displaying, how do you display the stuff? So we'll see that there are some examples. And if I have time, I'll look in the textbook and grab a problem or two out of the textbook. All right, so I'm going to gather responses to this question, and we're going to try to develop something from our data. What kind of sampling technique am I about ready to do? What would you call it? Say again?
Convenience.
Exactly, that's what I would call it. Because you're here, and I think I see 25 or 26 of you, and I don't know who you see because I can't see except 4 or 5. I'm just going to go down until people respond, and I'm going to collect data. So I'm just going to collect raw data about your favorite color. So you're representative of SRJC as a whole, just convenient. And there'll be some colors, and I'm going to try to abbreviate. For instance, if someone says aqua, aqua, oh my gosh, sometimes I have people come up with crazy colors. Okay, I'll use the letter A for aqua. But if someone says black and then someone says blue, if I abbreviate with a B, like even brown starts with a B, can't do it. So I might put the first 1, 2, or 3 letters just to abbreviate, and I'm just going to list it all here. So I'll start with Jan Norton because I see her first, and then after that, one at a time, chime in. If I hear something and you're talking over somebody else, that's fine. I might say, who was that again? And we'll try to collect raw data of, let me see how many people total. Oh, and by the way, do you guys see, maybe you guys don't, do you guys see anybody in the, what's called the waiting room? Yeah, so here's an idea. I see Frank Valencia in the waiting room. When I go into the mode where I'm showing you my document camera, I do not see waiting room people anymore. So something to be aware of. If you are, it's like class time. Oh, I'm in the waiting room. Nobody's letting me in. You might want to swap with each other phone numbers or something and say, gosh, it's been 5 minutes. Hey, Brianna, it's like, hey, Brianna, I'm here. Are you guys in the room? And then she would say, hey, Jeff, Frank's in the waiting room. And then I'll get out of what I just did and I can let Frank in, which is what I'm doing right now. And then I can go back in. So I'm hoping you guys can kind of help each other. Otherwise, you might be sitting in the waiting room for the whole time. Yeah, Emily?
If you make someone a co-host, I think we'll be able to see if someone's in the waiting room.
So okay, so I'm going to ask Jan. Where's Jan? Jan Norton? We're going to try this. Okay, would you mind exiting and coming back in?
Sure.
And then Emily, since you spoke up, I'm going to make you a co-host and see if it back gets through.
Okay.
Do you see that I made you co-host?
Yeah.
Okay.
I'm waiting to see her pop up.
Me too, because I haven't seen it. Oh, I see somebody different, don't you?
Yeah.
Yeah. Why don't you go ahead and let her in?
Okay.
Good. You're able to do it. That's good.
Yeah.
So you're right.
Because I think if you're like on the speaker view, you can't see it, but then I would be able to at the bottom.
I get it. So thank you for volunteering. And just remind me each time we come in to class, because I'll forget, Emily, that we did this once.
Yeah.
So from here on out, just say, hey, Jeff, co-host, and I'll say,
Okay.
thanks, Emily.
Okay.
Why don't you let
Is it possible for Emily, would you mind maybe posting your number in the group chat so we can text you to let you know?
Not a problem.
Thank you.
You're welcome. I will do that now.
Okay, so I'm going back into my little screen thing here. So, Jan, you back with us?
Yep.
Good. You get to start. Favorite color, Jan?
Blue.
Okay, just start. Be patient, one at a time.
Blue.
Red.
Pink.
I'm going to do PI for pink because somebody is apt to say purple. So PI.
Purple.
Thank you.
Green. Green.
Black.
Okay, so black I heard. I'll put BLA.
Blue.
Red.
Orange.
Blue.
Blue. Red.
Purple.
Purple.
Okay, I heard two people, but I didn't hear either one.
Blue.
Purple.
I heard purple again, and the other person that didn't say purple. Maybe I heard two responses. Okay, so keep going.
Black, which is not a color, a shade, but
Thanks for the clarification. Say again.
Green.
Oh, okay. So yeah, green. Got it.
Purple.
Blue.
Blue.
Red.
Green.
I heard a red, I thought, and I thought I heard a green.
Purple.
Two, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I have 24. How many people in the class? And I have 27. So it might be a few people thought they responded.
Red.
Okay, and didn't get a chance. Okay, I have one more there. That's a good thing. Okay, so we'll put red. And if that's it, that's fine. That's okay. So we'll just go with that. So if I'm not mistaken, I've got, again, 24, 25. I think there's 25 total, and we'll find that out when we make up this frequency table. Now, a frequency table, title it color, and we'll put FREQUENCY. And then the letter F sometimes is enough to represent frequency. Now, your textbook sometimes will include just before frequency, and it'll include a column that's called tally. Tally. It'll look like this. That's like your random variable X. So random variable X, I've used the word random. Okay, the variable X means color. The response will be color. And is color a qualitative or quantitative variable?
Quantitative.
Qualitative.
Qualitative.
There you go. It's a quantitative is a number, but you're giving me a word, so it's qualitative.
It up. Had a brain
Okay.
fart.
That's okay. We all have those. So your random variable here, and then maybe tally. Now the tally, and then the frequency here. The tally means you put something here and you got multiple amount. Like there's 3 on the first, maybe color, and maybe you got 5. You guys remember when we get up to 4, what you do with the 5th thing?
Yeah, cross it over.
Yeah, so it's like a little diagonal thing. That means 5, and so on. And then over here you'd have 3, and over here you have the number 5, and so on. But because there's so few, I think we can just forget the tally and just go directly to the frequency. So how I'm going to start is I'll pick the first one, blue, BLU, and I'm just going to count. And as I count, I'll scratch them off. When it gets to be like 1,000 responses, what I'm doing may not be the best scenario. You have to think how you collect data, raw data, and then how you're going to arrange it so you don't miss anything and make your life easy. But I'm just slashing blues. There's 3 of them. There's 4 of them. There's 5 of them. 6, 7. Okay, if I haven't miscounted, looks like there's 7 blues. Okay, looks like R for red would be next one. And so there's 1, 2, 3, 4. Okay, so red, there's 5. And the next one is PI for pink. So let's see, there's pink. Might be the only thing I have here, 1 pink. Okay, purple. There's 1, 2, 3, 4, 5. Hey, Jan.
Yeah.
I think your microphone might be on. It might be your background noise I hear every once in a while. Might not be. I'm not sure. Thank you. Let's see. G for green. One, 2. Two. So I'm wondering now, see, I try to make different scratch marks look differently. I'm wondering if I'm finished. Anybody see something that I might have missed? No, let's see, 12, 13, 18, 20. I have 25. I think that's what I said I was supposed to have 25. Okay. So I've got a total of 25 responses. The other column over here is usually reserved for relative frequency. RF, R stands for relative, F stands for frequency. Think of relative frequency. Sometimes is like probability. Now, I'm not defining what probability is. We have a whole chapter on probability in chapter 5. That's coming down the road. So just remember probability for later. Right now, it's being called relative frequency. Relative frequency is the occurrence that you see, which is the frequency for blue. So there's 7 blues out of the total 25. So 7 out of 25. And so therefore the red in like manner would be 5 out of 25. And then 1 out of 25. And when you add all that up, you get the number 1. Add up all the fractions, you'll always, and you have to get the number 1 when you add them all up. Now the relative frequencies, you have 3 choices on how to display those. You can either be fractions, percent, or decimal. And it's your choice. Fractions, percent, or decimals. Okay, so that's an example of a relative frequency. Sometimes they'll say create a relative frequency table, just relative frequency. I'm okay with you going frequency and then relative frequency, but they definitely want to see that column. Let's see. Sometimes they call it a distribution, relative frequency distribution. So distribution and table kind of go hand in hand. Frequency. Means the same thing. Now, in a bar chart or a bar graph, what you'll do is it'll feel like the XY axis. When I say XY axis, it'll feel like this most of the time. And okay, in algebra, which axis is this one, X or Y, the up and down, the vertical axis, X or Y in algebra?
Y.
Correct. So, but instead of Y, we're going to call it the F axis, like the frequency axis. And down here is maybe like the X axis. I'll just put X, but that's the random variable. So what you typically do is put the information down below. And for us, it's colors. So this would be like the legend color. And so again, abbreviate, I would put maybe BLU. And then R for red, and then PI for pink, and so on. Now, when I look at how I'm going to label my y-axis, the frequency axis, I'm only going as high as 7. For us, only as high as 7. So I think it would be okay to just put tick marks as units. 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Just to demonstrate this. If I had one color that was like 20 students and a couple of the other ones, then I might want, since my y-axis is kind of short, I go maybe 5, 10, 15, 20, in terms of the tick marks along the axis. I wouldn't have to put 20 little tick marks because it just gets it all clogged up or cluttered. But because 7 is not much, I can just have them spaced out like that. Here's what you do. Blue, okay, there's 7 of them. You're gonna make a bar, a rectangular bar. Now for homework, I'm okay with you freehanding it. Doesn't have to be a ruler, straight edge, things like that. If you're familiar with maybe Microsoft Excel or something, a program, those computer programs will just make them for you. You have to know how to set it up, but it'll make the bar graphs for you. You know, putting in the like the number 7 here just tells the person who's looking at it, that's definitely 7. This is 7 up the top. Sometimes they put little shading, just say, hey, here's my rectangular bar. You don't have to do the shading. It might be helpful to put the number in there. 5, 1, 2, 3, 4, 5. So the next one is going to be like this. And you don't, for a bar graph, you don't want to fill in the gaps. That's a different kind of graph. When you've got a bars and they're pushed together, it's not called a bar graph, it's called a histogram, and that's later on. Not today, I don't think. So bar graphs have a gap in between the bars, and then this would be the number 5. The next one is 1. The next one is 5. 4. to and then questions that will be posed on homework or myself on a basic bar graph could be, well, how many people total took the survey? Let's say they just gave you the bar graph and they didn't give you this. How many total people took the survey? And you'd say, well, just count the frequencies, 7 plus 5 plus 1, total people. What? Okay, here's a word for you. Proportion. Proportion. Now, proportion is a fraction or relative frequency. What proportion of those that took the survey indicated pink was their favorite? What proportion? And then you'd say, well, 1 out of 25. You can just look at it. What percent is the most popular color? What percent of those that were surveyed was the most popular color percent? Now, you have to go and say, well, it's blue. Blue is the most popular color, so you go 7 out of 25, but then you're going to have to turn that into a percent. And then you take your calculator, and you can go like this. You go 7 divided by 25, and hopefully that's a decimal answer, but to turn it into a percent, you move the decimal over so many places. How many places, Spencer? How many places do you move it over to turn it into a percent? Right, percent. Sorry, that's my phone, but I'm just going to ignore it. And if it's decimal, you would have 0.28. So it depends on the question that's being posed. In this case, I said what percent. I could say which colors were over 4. Over 4. Which colors represented something like that, over 4. Now the word over, does that mean you include 4? Over doesn't mean include 4, so you'd say it's blue, red, and purple. Those are over 4. So at this stage, this semester, you're going to see words like this. And I'm going to flip the page over here. This semester, you're going to see a lot of mathematical words that will look like this. You have to start getting yourself familiar with saying, oh yeah, I'm going to have to know, like, is less than, what symbol goes with that? Or that's even more interesting. This one's probably more commonly seen, but what if I used no more than? That's this symbol right there. Does not have the equal sign associated with it. This is the back of your packet. Decreases, fewer. Oh, sorry, less than or equal to. No more than does have an equal. No more than. That means you include it. My mistake. My mistake. Hey, I make mistakes too. Yeah, no more than includes the item that you're talking about. Fewer decreases is this one. At least, that's a very common phrase in our course that you'll see. That'll be this one, it includes it. Exceeds, no equal sign. Different. And so on. So I use the word over. I'll just up here. And so you have to say, well, what does that relate to with the problem that I'm looking for? And it may not be one of these symbols, but it has some connotation to it. All right, flip the page.
Quick question on the bar graph.
Oh yes, thank you.
Just real fast, along the y-axis with the frequency, would we ever label, like in the bars, we see it could be 7, 5, and 1, but on the left side, would we ever put like 1, 2, 3, 4, 5, 6, 7, or put in intervals?
Yes, no, sometimes you see 1, 2, 3. I think I said if you had a lot of numbers, maybe you go 5, 10, 15, 20. If I went 5, 10, 15. I would never do this when my tallest one was 7. I'd never do that. But if I had like, something like 18 was a response, instead of making 18 little tick marks, I just put 4 tick marks and go 5, 10, 15, 20, or 10, 20, and then you'd have to approximate where 7 is. And that's why sometimes it's nice to put the number in there that you want the reader to know for a fact how many there's actually in that rectangle.
Right. Okay, gotcha.
I almost forgot the pie graph. Now the pie graph, I'm probably not going to have you create one by hand unless it was a group quiz. And probably then I'm probably not. You'd have to have a compass protractor to make an exact circle, or take a cereal bowl or a cup. So in terms of creating it, I'm not going to ask you. I'll ask you to interpret a pie graph. Interpret. Now, if I were to put in 28%, here's the center. If I were to say, what amount of the circle is 28%? Well, I know that's 25%. That's a quarter. So maybe you go a little bit farther like that. And then you'd put in 28%. And then you'd say, maybe over here is blue. I can't even spell. That was weird. Sometimes they don't even put the percent in there, and they'll just have you approximate what that is, and hopefully you come up with a number that's reasonable. You wouldn't say that's 50%. You wouldn't say it was 25. It'd have to be more than 25 and less than 50. I think you'll see a couple pictures that I have photocopied for you to take a look at for a pie chart as well. All right, let's flip the page. If I have time, I'll come back to that. If I have time, I'll come back to that. Okay, what these now are just images that I took from, well, this was a PG&E bill that I had way back in 2000, PG&E bill. This was interesting because it shows PG&E has natural gas and electricity that we were using. This shows the way they have their bar graph going vertically, shows the amount of electricity being used for the month of August. And it looks like, I'll say about $102, 102. Now, from 102 up to about 130, I'm guesstimating right here, it's about 130, 102. That amount right here in the black shaded, I'd have to know that it's about 102 to 130. What is it, about 28? So that's about 28 bucks, and this is about $102. So together it'd be about $130 is my bill. And of course, as I'm looking here, I see an increase in electricity throughout the year. Definitely see the size of the, these are about the same in terms of natural gas. See, then all of a sudden it increases right here. Why do you think the dark is increasing in here?
Colder, so you're using the heat.
Right, that's probably telling you, definitely telling me, but telling you I have natural gas heating, central air and heating. And so, yeah, colder means I'm going to use more gas and so on.
I'm sorry, I'm not understanding what's the dark mean? It's older or colder?
No, right here.
Right, but I don't understand what that means.
So what he was saying is the reason that November through February, the length of the dark bars are longer than over here in June and July and August and September is because I'm using more heat. And in my house, it was gas heat, not electric heat. If you go back in your own home, you might say, what about your stove and your oven? Is it electric or is it natural gas? You might never, you just turn the darn thing over and, well, if you don't see any flame on your stove, then it's not gas. It's going to be electric heat. Fireplaces nowadays are natural gas. Fireplaces rather than wood. So during the wintertime, I think in this house I had a wood-burning stove at the time. But the house that I have right now is natural gas. So my gas bill is going to, and we use it a lot because we like the ambiance and it warms it up a little bit. Yeah, I'm paying a lot. So in terms of interpreting it, I think that was the key rather than saying, oh, you know what? This was your house, Jeff, and you used a lot of money here. $250 altogether. You see that right here? December. Back in 2000. Now that's a lot of money. Right now, to do the same thing would probably be $400 to heat and have my house lights on. Here's another one that's different, and the only reason why I'm pulling it over and saying different, two different things, is look at the bars are going left and right. So that would be indicating to you, well, it'd be a horizontal bar graph. And this actually tells you where my natural gas is sitting. Look at the dark and the dark. Central heating, hot water heater. And I have I had a gas dryer. The wash machine was electric. That's what it's saying right here. Okay, here, if I look at the bars first and look at the information, it talks about spam. I'm seeing the number 2002. So the year 2002, and all this is talking about spam. And up here, this y-axis is talking about the monthly spam attacks in millions. Let's see, unsolicited commercial emails, and it's probably maybe nationwide. It's hard to tell, like, is this just California? So you have to read the whole thing. 3.5 million monthly spam attacks is up here at the top. Well, look what's happening right here. In algebra, that kind of curve, we call that like a function. Anybody remember the word for that if it continues to grow this way?
Exponential.
Thank you. Good job. Yeah, exponential growth. It looks like spam, unless they get it under control, is going to be out of control. And so they have to have maybe some of those, what do they call those? You get, oh gosh, I can't even, McAfee, whatever McAfee is, you know, where they, can't remember. You guys will have to help me with the word.
Like an antivirus software?
Right, that's it, an antivirus, and maybe they'll have an improvement in the spam, and it's always changing because everybody's trying to hack into your stuff and send you unsolicited emails. And now it's phones, you know, phones. I'm always getting them from places. Anyway, exponential. Now look at the bar graph right here. So now you see kind of wedges or pies, and that's pretty common to help you, give you more information than maybe than you do on the bar, more information so you can understand what's going on with the pie graph. Okay, that's just, all this is an illustration of the types of graphs. Timeline graph, timelines. Now, I've kept this on for a long, this is, okay, I've taught for a long time. So I would take, a long time ago, articles from 20 years ago, and I've kept them because it's interesting to see, for instance, what's happened with the Dow Jones, 1996. This is the year 1996. And some of you say, I don't have no clue what you're talking about the Dow Jones. It's the stock market. It's one indicator of the stock market. And currently, if you Google Dow Jones, it's about 29,000. Just think of the number. Don't understand what it's doing. If I look at here, it looks like at the end of the year, it's 6,500. So 29,000. So it's gone up. Now, most all of you lived or have heard about the Great Recession from 2007, 2008, the Great Recession. The stock market at the time was about 18,000. Pretty healthy. And then it took a crash, and it went down to a third of what it went down to 6,000. A lot of older people who were on fixed income, it really hurt because it took some time to recover. And some people were panicking. And I myself was wondering, gosh, is this going to be forever? I'm, my nice little nest egg is now only a third of what it was, and blah, blah, blah. No, people said, be caught. This has been a while, and we almost unheard of since the Great Depression of the 30s. So luckily I didn't do anything, because you know why? Because it went from 6,000, that was 2000. See, this is 1996 right here. Where is it? 1996. That was what I was talking about. It was 9 or 10 years later, it went back down. Oh, I'm back up. Matter of fact, I made more money. But things could happen again, right? So I'm not here to advise you about the stock market. I'm just here to show you that this is a timeline, and it's very interesting because a lot of people try to predict behaviors to try to make money in the stock market. And a few people do, but not a lot of people. Probably more people try to predict it and lose money. So I don't know. It's up to you what you want to do. Timeline. Okay, so we'll get to this in a moment, this next page. I'm going to go back to the page that I skipped over. And what haven't I done? Maybe I'll do a relative frequency distribution and relative frequency bar graph, okay, and see what that looks like. And let's do it on what I suggest is size. Now, when you look at what's it, 2000. So this is we're in the presidential election year. So back then, this is in Nevada, all the counties. Well, how many counties have Nevada? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 counties make up the state of Nevada. And at the time, here are, let's see, what does it say? Presidential results. It looks like this was how they voted as a county overall, if I'm reading it right, because it says election results. Republican, Democrat, Republican. Okay, it just by spot checking, it looks like 8 years ago, it was a Republican state by just the look of it. Now, size-wise, this is the size of the county. Now, I don't have what constitutes number-wise the size of small, medium, large. I don't know. That's not the point of this. The point is, let's make a relative frequency distribution based on size, which again, size is a categorical variable or qualitative. So what I can do is say, okay, I've got X. So you'd say maybe X is equal to size, my variables. So you'd have small, medium, or you could have gone large, medium, small, or mixed it all up. It doesn't matter to me. But I'll say a small, medium, and large. And for me, I have to do frequency first, and then I'll do relative frequency. Relative frequency distribution is my target. So eventually I'll need that. I think I'm going to actually put in the tally just to show you how this might work. So I'm going to start from top to bottom, left to right. I'm just going to put in a tick mark for everything I see right here. So medium, I'm going to put it like a tally mark right there. Here's the next tally mark. Large, tally mark. Medium, medium, small, 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 and again, No, I'm scooting over here. Now, if relative frequency was all I was needing and it didn't say like how to display it, I'd be done. I'm thinking of maybe the relative frequency bar graph. They may say make a relative frequency bar graph with respect to percent. They might say that. So I'm going to assume, I'm not assume, I'm going to do it that way by percent. So I'm doing squiggly. I'm going to change these to percents. Now, because dividing by 17, I already know, I'm not going to get a nice exact answer. If I do 9 divided by 17, yeah, I'll get a decimal that goes on forever. So here's what you have to do in like an approximation. And some of you struggle with this in terms of rounding. Maybe not today, Wednesday. I'm going to have a sheet from last semester, actually during the summer, that will indicate, I'll call it rounding rules that we'll live by in this course. Let's see, the rule that we live by in all of mathematics would be, let's say we go to hundredths. I'll just use hundredths place as an example. If I run around to the nearest hundredth, so I'm looking at the 2. The 2 is in the hundredths place. And I know there's a number of you in this class that don't know your place value. So there's your decimal place. The first place value is tenths with the th, tenths, hundredths with the th, thousandths, and so on. So that's an arithmetic concept. And if you need help with that, see me outside of class or Google it yourself. So if I'm looking at hundredths and I went around to the nearest, you always look next door to the right. Boop, there's the 9. If it's 5 or bigger, you're going to round that to up to a 3. So what I'm looking at, I would round that to 0.53. Now, what if I went around to the nearest thousandth? Thousandth. So that means place value right now is at the 9. So am I going to round that up or keep it the same? Well, you're going to look next door. I see a 4. Oh, that's below 5. You're not going to change the 9 higher. You leave it alone. So if it's the nearest thousandth, you would end up having 0.5, 2, and a 9. That's the nearest thousandth. So let's do, for our sake, nearest hundredth. So, and the reason why I say nearest hundredth is because I'm looking at percent. 100 is in terms of percents, hundredths. So wouldn't you also do it this way to turn it from a decimal to a percent? You move the decimal over 2 places to the right? The answer is yes. So if I do that, it's going to be 53%. Most of you would recognize that anyway. Exactly 53%. Not exactly, but it's rounded to 53%. That's what I'm going to do is it's about 53%. And now I do same thing, but 6 divided by 17, it looks like. It's about 35%. 35%, okay. And then I'm going to go 2 divided by 17. And if I went 2 decimals, 1, 2, gosh, it looks like about 12%. See, if I move it over to 2 decimal places, or if I look at the hundredths place, that's going to go to a 2 because 7 is bigger than 5. Yeah, so 12. Now, if I add this up, it better be 100%. Or because I've rounded it, it's going to be off a little bit. Let's see what I get. 8, 0, carry the 1, 6, 7, 8, 9, 10. Hey, well, I sort of got lucky. Because sometimes if you start rounding, you're not going to get exactly 100, and that's okay. I'm all right with that. So now what I'm going to do is make a bar graph. And this would be S for small, M for medium, L for large. And this is percent, which is the relative frequency axis, relative frequency axis. And since it goes up to 100%, I can make that up to 100%. But look at, I'm only going up as much as 53%. So why go over 100%? I might as well go 10, 20, 30, 40, 50, 60. Maybe you can write 60%. So if this is 10%, I'm going to make my first bar 53. So I'm going to go up here. It's approximating, but maybe you want to go 53 and put your percent in there. Medium is 35%. So 10, 20, 35. Okay, gosh, that's 2.1 right there. Any general questions before I get into the 2.2? Any questions you have of me about what you've seen thus far? Yeah, go ahead, Spencer.
I have a slightly separate questions about the handbook. Can I ask you after class?
Yes, absolutely.
Cool. Thank
Yep,
you.
no problem. Any other questions out there before I flip the pages?
So what we did right now, for the first graph on the left, if you will, that's relative frequency distribution.
Right here?
Yeah.
Yeah, sometimes we'll say it's a frequency and relative frequency distribution. Your author's probably going to ignore that, but I think it's helpful to do it. And I'm okay with it, is to include the frequency column. But ultimately, I was targeting the relative frequency. Instead of the word distribution, they may say table. Sorry, we're looking in the textbook. All right, very similar. Actually, it's the same one. Oh, yeah, it's the same one, 2012. Yeah, same one. But here they're saying about vote. So this one here would be regarding the Republican versus Democrat. When they see how they say this, Enrique, distribution, that means a table.
Got it. Thank you.
Yep. Relative frequency distribution. I just did number 14 for you, guys. I just did number 18 for you guys. This whole cross tabulation, I'm not teaching, so you're not held responsible. I should not have given you problem 29 in your homework. I should not have, because I'm not teaching cross tabulation. But I could give you 11 through 20 for sure. For sure. All right, let's flip over to 2.2.
Really quick. So are we not doing 21 on the homework?
Did I assign 21?
I don't know. You just said you shouldn't have. So I wasn't.
Yeah, well, it didn't mean I did. I'm just looking at the phrase cross tabulation on a rare occurrence. Oh my gosh, I can't say it. On occurrences, that's not bad grammar too. Sometimes I have 6 classes. I'll go through and I'll say, yeah, it looks good, and then I don't read the problem all that carefully, and I grab it accidentally.
Okay.
And maybe you'll say in an email, Jeff, you never covered this. Am we supposed to know this? And I would say, oh gosh, no. Okay, I'm looking at number 21. I mean 2.1. Yeah, see, I don't even give you 11 through whatever. I'm giving you looks like 2, 3, 4, 5, 6, whatever that is, and 23 through 36. That might be something similar, but it shouldn't have cross tabulation as one of the questions.
Oh, darn it. The 2 you gave us, you didn't even assign.
Can you guys see my spreadsheet here?
Yeah.
All right. Notice on 61 and 62, it ignores the letter E. You see that? That's not a mistake.
Yes.
It's only A, B, C, D, and it skips over to F. It's because E, I had to be selective. E is not a good one because I didn't cover it. I want to see what E was all about. I'm curious now. 61. Oh, okay. So, yes, you know how to do, can you guys see what I'm on my screen?
Yeah.
There's
Yeah.
my big arrow. Have fun squiggling this around. You can see a big arrow. Okay, relative frequency, yes. Frequency bar graph, yes. Yes. Where is that? No, Pareto chart. I didn't teach that. I'll never teach it. So that's why I didn't pick E, because I'm not doing that one. But F, pie chart, yes. Do it. Just try it on your own. Do a hand drawn circle for the most part. Okay, 2.2. What am I doing time? Okay, we start at 12. Okay, I can do this. Okay, 2.2 has quite a bit in it. I'm going to streamline it for you. I'm not going to cover this. I'm going to give you ideas about what's happening, but I'm not going to go in great detail. It turns out this exact problem is right out of your textbook from the author. This problem right here. I just copied it right out of whatever the author did. You can find everything here. So just make a note of that. The big thing is, as you can see here, there's a bunch of numbers, is 2.2 is about quantitative values or variables, where 2.1 was about qualitative. So there's a difference. 2.2 is where there's numbers. 2.1, there were no numbers, just words. So how we can handle quantitative, we have a lot more choices. And most of the problems for the rest of the semester is going to be quantitative, where it's numerical in nature. So that's the first thing. Notice there's a bunch of numbers. In this section, you're going to be shown what's called classes. And you can even see the word down here, classes. So it's how you're going to group things together, group them. And I'll just kind of give you an overview. If I sort of listed all these numbers, isn't there the number 1 through 8 here? You see that? Jeff says, okay, 1 through 8. So if I did a number line, and I went the number 1, and I went 2, 3, 4, 5, 6, 7, 8. And I want to bust this up so that I have, let's say, 3, let's see if I can do this right, 3 classes. Now classes, groupings, 3 groupings that would all have the same distance, I'll call it distance. And let's say the first grouping would be from the number 1 to 3. So here's 3. So I'm just gonna go like this. There's one grouping. And then this is the number 4. So it looks like I'm encompassing, at least in this case, 3 tick marks. And I circled the next 3 tick marks. And over here you say, Jeff, there's only 2 tick marks. Oops. Here's what could happen. The number 9. There is no 9. So there is no 9 right here. So let's just, for conversation's sake, it'll be a little funny because I don't have any 9s. I only have them up to 8. I'd actually have 3 classes in the last class, but I only have 2. So if I want to capture the same number of tick marks, you start with, let's say it was 3. I would have 3, 3, and whatever's left over here. All right, try something else. How about groups where you capture 4? So you start with 4 like this. Well, there you go. I've got 4 in each. What if I wanted pairs? So here's a pair, there's a pair, there's a pair, and there's a pair. So sometimes you can capture it all, sometimes you can't. Now, when I look at this thing called histograms, so don't worry about the class and the class limits. We may have to ask that question on Wednesday. Hey, Jeff, what's the difference of what you want us to do and what the author does? We'll talk about that on Wednesday. I'm going to flip this page where it has a bunch of raw data for MLB, Major League Baseball, as of 2015. 49 all-time home run leaders, 1, 2, 3, 4, 5, 6, 7 times 1, 2, 3, 4, 5, 6, 7. Okay, 7 times 7, there's 49 numbers here. And I've already ordered them from lowest to highest. Of course, Barry Bonds is the highest as of right now. And down here, I don't know who that is. And maybe some of you know Alex Rodriguez, who's married to J-Lo, Jennifer Lopez now, and he was a baseball player for the Yankees. And Lou Gehrig is in here, Babe Ruth is in here, and some of the other famous people too. Now, instead of finding classes and class width and all these here, instead of doing all this, I'm not going to. I'm going to show you how to create the histogram, which is based on classes, but it can be confusing from the author's point of view, my opinion. So here's raw data right there. Go to the next page. For histograms, I call the classes rectangles. I'll call because what you are going to have is a bar graph, but all the gaps are pushed together. There's no gaps in between the rectangles. It's called a histogram. So bar graph pushed together, it's called a histogram. You want the bars, since it's a rectangle, you want the width to be exactly the same. You want the width to be exactly the same. And I'll show you how to do that. Sometimes I call them piles instead of rectangles, and sometimes I call them bins instead of rectangles. And the author will even talk about the average number of rectangles from 5 to 20. That's the target you want. Now, if I had numbers on a number line like this, and here's the number 0, and there's the number 5, and the number 10, and the number 20, and the number, excuse me, number 15, my mistake here, 15. And the number 20, and 25, and so on. Do you see how the distance between is exactly 5? I think that's obvious, isn't it? That's called the width, by the way. The width is 5. It's obvious. Right here, width equals 5. Now, the piles or rectangles are indicating to you between what two numbers is your response sitting in, between what two numbers. So for instance, let's say you have a bunch of raw data and you've got the number 3. Wouldn't 3 sit in here? Here, I'll do the raw data. Raw data. Let's say the first raw data, wouldn't it sit in here? I'll just put it like a tally mark. I'll put a tally mark. Tally mark, not a digit. Okay, the number 4, wouldn't that sit in here too? Oh, another number 4. That's another tally mark right there. The number 11, well, that sits over here as a tally mark. Now the number 5. Okay, 5 is right here on the edge. 5 can't sit in both piles. It can't because you're double dipping. You have to make an agreement or a decision. Does the 5 sit over here or this 5 sits over there? So here's what we're saying. As a rule of thumb, anything that sits on the border, like the number 10 sits on the border, it's always going to be to the pile or rectangle to the right. So the number 5 is going to sit over here. That's the agreement you're having with me, and the author does the same thing. So in developing this, you first got to figure out, oh, okay, what's the width that they're talking about? Well, before that, sometimes they'll say, how many rectangles do we want to display? Because that'll help determine the width. So let's start with that. How many rectangles with 49 data values, and your number of rectangles or bins are from 5 to 20, how many rectangles? I'll let you guys, I'll take a couple, 2 or 3 responses. There can be wrong answers, I'll tell you. How about 100 rectangles, Jeff? No, you're outside 20. That's not a good choice. How about no rectangles, Jeff? Well, that's dumb because you want something to see. So 5 to 20 and you have 49. Anybody have an opinion on how many rectangles that represent or where these numbers can go?
10.
Or one person say 10. I'm not going to respond whether they're good or bad or indifferent.
Gracias.
Oh, somebody else. How many rectangles? You may not completely understand that yet, but you have 49 numbers and all the numbers have to go into a pile or a bucket. How many
Maybe
buckets?
7.
How many?
7.
7. So I have someone with 10, someone with 7. One more person.
15.
Okay, 15 or 16. So I'm going to say no to the 15 or 16 because with only 49 numbers here, you probably have some empty buckets. The more buckets you have with not a lot of data, some of them are going to be empty. So I'm trying to have a proper number of buckets or rectangles. You don't want just one rectangle because then all of them are sitting in one bucket. That's not very interesting. So someone said 10, someone said 7. That's a little bit more like it. I'm probably going to focus on the number 7. What if I had 49,000 data values? 49,000. Well, 7 buckets is not, you need more. And I'll probably say maybe even more than 20 would be better with 49,000 data values. So for you guys, I'm probably never going to have you do 19, 17, 16 bins. Never going to do that. It's always going to be around maybe 6, 7, maybe 8 at the most, somewhere around there. So let's go with the 7. 7 rectangles or classes. So I'm going to look at this. So I'm going to flip the page over. It's the same data on the next page. How to create a histogram. We got to know how many bins we're going to have. So we're going to have 7 bins. And now I need to know what the width of each bin is. So this is how you do it. The width is the range divided by the number of bins. Oh, the range. So the range is the highest number, subtract the lowest number. So the width equals the highest minus lowest divided by number of bins. Our highest number is Barry Bonds's home run total. Subtract the 414, all divided by, we want 7. And so what you're going to do is you're going to take your calculator and you're going to go and do a little arithmetic and divide that by 7. And I don't get a nice number, so you're going to have to make a decision. Probably most of you are going to say, how about 50? Because that looks pretty decent. Not a bad decision. Someone else might say, I would have picked 49, Jeff. Try it. Here's the caveat. When you pick your width, the two things that have to make sure you absolutely stand. Your first bin that you create has to have a number in it. It cannot be empty. And your last rectangle bin cannot be empty. The bins in between could possibly be empty, but your first and the last cannot be empty. That's the only thing. So whatever number you pick, whether it's 49, 50, or even 30, if you want to pick 30, no problem as long as you have exactly 7 bins for this problem. The first one and the last one cannot be empty. So now, if we say, let's round this up to 50. That's your width. So here's the histogram. I go like this. Lowest is 414. You see that? There's no need to go all the way down to 0. If your markers are every 50, why do you even start at 0? You don't do that because you'd have your first bin be empty. I'll say that again. If I go from 0 to 50, what of these raw data will be from 0 to 50? Nothing. So I'm going to go like this, squiggle, squiggle. It's pretty obvious, not obvious, but used a lot. I'm not going to use anything until I get to maybe, let's try 400. Because look at, the first one is 414. Let's start with 400 and let's go, the next one is what I'm doing is I'm adding 50 each time. So here's my first bin right here. So that's 450. The next one is 500. The next one is 550. The next one is 600. How many rectangles or bins am I supposed to have again?
7.
7, right. So right now I have 1, 2, 3, 4. I'm only allowed 3 more. So let's see what happens. 650. What, 700? 750. Okay, 1, 2, 3, 4, 5, 6, 7. I have 7 rectangles or 7 bins. The question is, will every single one of my numbers from 414 all the way up to 762 sit somewhere? Or is there some numbers that won't fit in here? Will 414, like that's the lowest one, will 414 sit somewhere? Well, of course, it's in between these two numbers.
You're going to lose your highest number,
Right. That's
at least.
That's a problem. Your highest number can't fit. So
Actually, there's at least a couple that won't fit.
so this won't work. Now 50 isn't the problem. It's where we may have started. So here's a hint, because it'll always work, or 99.9% of the time it'll work. Don't start at 400. Start at the lowest each time. Why not start at the lowest? So I'm going to do this over again. And where am I going to do it? Oh, shoot. I'm going to do it on a separate piece of paper. So the first marker is 414. Now I'll still add 50, and I still need 7 bins, so still add 50. Now the arithmetic gets a little squirrely for you guys, but that's okay, you can do it. So I'm hoping I can do it too. 464, let's see, 514, 564, 614, 664, 714, and then 764. Let's see, 1, 2, 3, 4, 5, 6. I got to stop. Oh, I think Barry Bonds will fit in here, won't it? Won't he? It will. Oh, and will somebody sit in the first one? Like 414, doesn't it go to the one to the right no matter what? That's what we agreed on. And Barry Bonds is the last one, and it's going to fit in there. So first one and last one is not going to be empty. And now I don't know what happens in there, but I'm going to find out here right now. I'm basically going, this is a frequency on the side. I'm just going to start counting. How many numbers, home runs, are from 414 up to, but don't include 464. The reason why I say don't include that, because 464 goes over here. Remember that? The ones on the border always go to the right. So 414 to 463. Luckily, these are in order. 414 to 463. Well, there's no 463. So it goes up here. So I'll just count them. 2, 4, 6, 8, 10, 12, 15. 15. 15. 5, 10, 15. Okay, now I start with 464, which there wasn't any, that's okay. And then I go up to, okay, what number will I stop at on this one?
513.
So I'm going to go to 513. So let's see, 513. Okay, well, I'm starting with 512 then. 2, 4, 6, 8, 10, 12, 13. 13. So how you're going to do this one is you continue rectangle over here until you get to the next tick mark. See, there's no gaps. And this was, what did I say, 13 or 12? 2, 4, 13. Okay, so 514 to 563. Okay. See, there's a 563. That's good. 564 would have gone in the next one. So let's see. I'm going to go over here. 2, 4, 6, 8, 9. If I've counted right, 9. Okay, 564 to 613. 613. 5, 6. Looks like there's 6 if I counted those right. 6 of them. $516 to $663. 663. Just these 3 right here. 664 up to 713. 713. Oh, okay. This is actually a good example. You see the 714? That sits on the border. It goes over here. That's empty. No rectangle there. And then the last three are right here. So this is a good example because there's a gap right here, but that's okay. And I'm going to put the word S-K-E-W-E, skewed right. This will, you'll see this phrase coming up, if not in today's homework, but soon. There'll be something called skewed left, skewed right, and then symmetric. Symmetric would be like the bell-shaped curve, symmetric. But this is skewed right. They might even call these three baseball players, home runs, outliers. Like there's not a lot of people are going to hit home runs like those three people. Likely. They're outliers. And that's how you create your histogram. Now, there's one more little baby topic on the back side. I think I only gave you one, maybe two homework problems. I'm going to wait until Wednesday to cover what's called stem and leaf. I think we're just going to go up to in 2.2, the histogram. This will be enough for you to kind of work on for the next 2 days. So 2.1 and 2.2, do as much as you can. Now let me get out of this and tell you what we get to do next, which will be.
Question before we move on.
Let's do that. Let's ask a question. Yeah.
I'm like extremely confused and lost as to how you determine how many bins you need.
Good question. So if there were 1,000 data values, more bins is probably better than just 50 data values. It's a subjective decisions. 50. Well, okay, well, if I have 50 data values, maybe 5 bins, 6 bins. If I have 1,000, well, maybe 19 bins, 18 bins, 20 bins, rectangles. So we had 49 data values. 7 bins, 10 probably would have been okay. Beyond 10, I think you're pushing it. You'd have quite a few. See, this is telling me something. You know, this picture. And this is what you guys are going to be recognizing. What is this distribution telling you? Well, it tells you that more of the home run leaders are in here, right? Isn't the vast majority of them right here? Between 414 and that's kind of the average. Like this year, well, this year's weird. Last year's home run highest batter is probably somewhere in here. Kind of unusual right here. That is highly unusual. Anybody's going to be hitting out there, highly unusual. So the distribution is kind of telling you something. If you've got too many bins and you've got too many of them empty, it's hard to interpret what's going on. And if you only have like two bins and they look like this, let's say I had 2 bins and they look like this. One's up here and one's like this. Well, that's not telling you an awful lot, or at least to me. This is telling me something that's interesting. And then you can have a conversation with your fellow statistician. So there isn't, like usually on the test, I'm going to tell you how many bins. On the test in the quiz, I tell you how many bins to use. So you don't have to guess that. If I told you how many bins, then you can work the rest of the problem out like I just did. We came up with 7 bins. I said, okay, let's pick 7. I'm going to pick for you on the test and on the quiz.
Okay, I got it. I got confused because I was looking at like the numbers like 400 to 764, and I was like, wait, how does the number 7 come to play? But now how you explained it, I get it. I get it.
And it's not because there's 49 divided by 7 is 7. It has nothing to do with that. If there were only 15 numbers, I don't even know if I'd do a histogram. I don't think there's enough data to really do it justice. So I guess the total number of data should be around maybe 50 or more to be worthy of a histogram. Otherwise, just do a bar graph instead.
Okay, thank you.
Okay, so I've got like 15 minutes left before you go. Today is your first baby quiz. Hey, this is good because it shows you what to do. It's only on 1, 2, and 1, 3. You'll find out, hey, it's only 2 sections and it's not a lot. And you'll have somebody else in your little breakout room to discuss it with. So here's how this is going to work. And I'm going to help you get started where to look for this because I haven't even published it yet. There's 27 people, so it looks like I'm going to end up putting pairs together, and then one group's going to have 3. You're going to open up the quiz, and you're going to answer the quiz on Canvas. And the quizzes are going to be true, false, multiple choice, push the button. And I think there's only 3 or 4 or 5 questions typically on a quiz. And when you're done, that's all I've got for you today. I'm not going to give you a time frame. I'm going to keep the rooms open until everybody's done. And I'll be jumping into your room if you need any help, or I'll be in the main room, which you can click on, say, ask Jeff for a question. So I'm going to show you, I'm going to turn it on first, the quiz, and show you, make sure everybody sees daily quiz number 1 is active. So give me a second here. Or 2. Yeah, it looks like there's 7 little quizzes. I said 5 or 6, but it looks like there's 7. Oops, shoot. Okay, publish. Okay, go into Canvas, look under assignments, I think, and or quizzes, and see if you've got your little quiz.
Yeah, it's under quizzes.
So when you hit, might even be preview or take the quiz. Let me go in as a student and you'll see me as well. Let me show you this. I'll share a screen. I'll do basic. I'll do this, show this. I'm gonna go in as a student. Hello, let's go over here. I'm student view. Hello, come on, student view. Oh my God, okay, finally, good, good, good. Let's go into assignments. I'm just gonna look there first because usually everything is under assignments. Not those guys. Daily, okay, right here, daily quiz number 1. Open that up. I'm a student right now. Oh, take the quiz. So click. And with your partner, you're going to look and read, and you could agree or disagree. You're taking your own quiz, though, but you got somebody else to talk to about this. And then when you're done, that's all I have for you today, and then you're welcome to leave, okay? And in the future, this is what the baby quizzes are going to look like or feel like. Okay. Anybody not able to find the little quiz? Anybody not able to find it? Okay, now I'm going to put you in breakout rooms. If you've never been to a breakout room, you're going to get an invite, or it'll say, join this breakout room. 2 per room. Why is it 2? Or maybe I'm, Emily, I'm going to unhost you because you won't be assigned a breakout room, okay? I don't think so. So I'm going to withdraw the host permission. Okay, let's see if that makes a difference. Huh. Okay.
Jeff, have you taken roll?
I'm not going to today.
Okay.
Thank you. So I've got 13 rooms. It says 26. I don't know. Maybe it's counting me as well. So I'm going to create the breakout rooms right now. And I'm looking, double checking to make sure I'm not part of this. I'm looking sure that everybody's got, you don't see what I'm seeing yet. And it appears I don't see my name and I see everybody else's. So I'm going to open it, and then you'll see your invite and just go ahead and click open and you'll join somebody else's room and you can get started on the little quiz. Elizabeth, are you able to do this right now?
No,
Okay.
I sent you a message privately through the chat.
Okay, so I didn't read that. So
I
give me a moment. Give me a moment. I got to move somebody into another room. Okay, give me a moment.
Okay.
Elizabeth, I'm looking for Elizabeth. Okay, right here. Okay, I think I'm good. Everybody's in their room.
Okay. Yeah, for some reason it's weird when I'm in my car or my truck, I can't it puts me in a safe driving mode.
So you want to chat for a bit and then you can take the quiz on your own if you wanted to.
Yes, and I will send you, I just got my DRD letters. So I will put that in your email today. I'm going to be able to get everything and I should be able to get caught up. I have a friend who took statistics, so he's going to help me with it. I just want to know how I can watch the videos of the 3 classes that we've had so far.
Okay.
And I should be okay.
I'm going to demonstrate that to you.
Okay. I really appreciate you understanding everything right now. This is really surreal to me, so I appreciate you helping me with this.
You're welcome. Okay, now in your Canvas homepage,
okay,
there's this thing called Tech Connect. I don't know if you can see this on your
yeah
phone.
yeah
Okay.
I'm screenshotting as you go.
Okay, so Tech Connect, and you'll see all the Zoom stuff.
Oh, okay.
Then the recordings, past recordings, will be under Cloud.
Wow, okay, that's
So
easy
go into
enough.
Cloud, and here's your previous two classes we did. Today's not up yet because I haven't finished the class.
Okay.
So when you click on one of these, which I'll do right now for you and show you, you'll have a variety of choices, and I don't know yet how to limit this. So pick one that's got probably the biggest gigabytes. Like, let's try this one and see what happens. I'm just going to pick this. You want to make sure you see the video as well as hear the audio. And there might even be some closed captioning, which this one does over here.
You could email it to me.
And then Jan, you might put into the chat. You see how that works? If you're okay, comfortable with this, putting your email down. So that's where you find it, Elizabeth. And it seems to be working the past 2 classes, and it'll be also today. Probably about an hour after class is done, you can see today's lecture. You're muted.
So we have a book and then a workbook, right? I understand.
Yeah, the workbook is just for your benefit
Okay.
while I do a lecture. You're never turning the workbook in.
Okay, and then the PDFs for that, someone, you said something about
I'm
today.
sending it to you this afternoon.
Okay, perfect.
So you don't
Sorry,
have to
it's
go
so
to the book.
smoky out here.
You don't have to do it through the bookstore now. I'm just going to send you the free PDF version.
That's so awesome. I appreciate that so much.
So the little baby quiz, make sure you go in here soon.
Yeah,
and take it.
I'll finish it before we have class on Wednesday.
Okay. Typically,
Mhm.
I put a time limit on it, but with everything happening right now, I may just leave it open. So right now.
And how do I get to the quiz? I just want to make sure I know how to get to that too.
Okay. Okay, under assignments, you see this assignment button?
Yes.
Yours won't look like this. Yours will look like, okay, I'll go in as a student then. Show you what a student looks. Okay, under assignments right here.
Okay.
You scroll down. And you're looking for, here it is, daily quiz, right here.
Okay.
Like the little airplane. You turn that on, and then you just start the quiz. Start the quiz.
Okay.
Mine says
Perfect.
resume, but you'll start it.
Okay.
Okay?
Yes. Thank you so much. I really appreciate it. And I will see you on Wednesday. And if I have any questions, I'll probably just email you is the best way to get a hold of you. Is it better to email you directly instead of through Canvas?
No, either way is fine. Either way.
Okay. Okay, cool. All right. Thank you so much.
Okay, Elizabeth, take care.
All right. Bye.
I think we could just leave the class in general. Yeah, I think I'm just gonna leave. All right, well, pleasure. Take it easy. See you later.
Hey, Jeff. Oh, what? He was just in here. Now he left. Maybe he went into the breakout rooms finally. My God.
Okay, some of you are wondering, which is reasonable to say, hey, hold on a second. Last three problems has to do with today's lecture, which wasn't supposed to be there. That's the first thing. So bottom line is I'm going to change everybody's score to 10 points at the end of the day. Some of you were putting in words that weren't spelled right. Oop, but you got the right idea. Or you put an S, plural, whatever. Oops. So it was all supposed to have been multiple choice true, false. And there were some fill in the blank, and that wasn't supposed to be either. So just to let you know, this is a good experience today in that you know how these little daily quizzes are going to be put together. And that at the afternoon, I'm going to end up changing all your scores. If it wasn't 10, it's going to be 10. And then we'll try number 2, hopefully be more successful on my end, that it's all multiple choice, true, false, and there's no mistaken right answers. Does that make sense? And also it's the material that we were supposed to have covered, not the day's lecture. So with that in mind, what questions do you guys have?
One other part about that is that the quiz was timed and it did submit answers at the end. I don't know if we were on a time limit or not.
Yeah, you originally were, and because of this whole fire thing, and I'm going to undo that for the future quizzes. So going forward, there won't be a time limit of 15 minutes or an ending. Yeah, I can see the time is about 2 o'clock because class ends at officially at
okay, yeah.
1:50 officially. That's probably why it cut off. So for the future, there'll be, I'm going to call it unlimited time, but I won't put the timer off. And hopefully the quiz I'll have checked also that it's just multiple choice, true, false. And we'll try it again. Number 2. But right now, 10 points for everybody at the end, sometime today. I'll go back and change it.
Thanks.
Any other questions about the
thank you.
quiz that you're curious as to maybe why you missed it? Because someone was asking the question number 5, for instance, how do they get the relative frequency? It was today's lecture, but in general, they just wanted to know how to get today's relative frequency. So if there's any questions about the quiz in general, I can answer those. But everybody's going to get 10 points. If you're just coming in, sorry, I couldn't get into your room because I was making a general announcement. At the end of the day, I'm going to give you 10 points because my bad, should have been not timed, number 1, for today for the first one. And number 2, it should have been multiple choice, true, false. And the last 3 questions were about today's lecture, and I shouldn't have had that. So there, I learned. So any questions on your part?
I just had one quick question.
Yes, go ahead, Richard.
So for the question regarding the pie chart, I believe the question was saying whether or not it represented qualitative or quantitative data, if I'm correct. I believe you put the answer as quantitative, but wouldn't it be qualitative?
Okay, I'm going to go take a look and see right now for daily quiz number 1. Let's see. You talking about number 1 or?
I think it was a little bit more towards.
Oh, right here. So true, false, a pie chart is used to represent qualitative data. That should be true.
Gotcha. Okay.
What did you put? Generally speaking, it's regards to.
I put true.
So sorry, did you say that the answer was true?
You did say it was true?
Yeah, but it.
But the answer key showed false?
Yeah.
Yeah, sometimes, now on occasions, now that's kind of a weird thing. Sometimes my answer key, I put the wrong answer in, and that needs to be corrected. So in the future, if you find something you want to question me about, hey, Jeff, this particular problem, I don't understand why it's false when in fact I think it's true. And then I'll say, you know what? I agree. So then I go through and I change your score right where you're sitting. And then I go back and put the announcement out for everybody, or I go back and check everybody else's and see if in fact they marked it wrong and give them back the 1 or 2 points. And then let them know by email, this is what I did.
Okay, cool. Thank you.
Yep. So in general, ask me, because you never know. And then for this quiz, everybody gets 10. And we'll try it again the next time on the next daily quiz. Technology gets me sometimes.
It's all
how to
good.
input this in. Yeah.
Thank you.
All right. Anybody else have a question? If you don't, then that's all I have for you today. If you don't.